Hello, I didn't see you there. Welcome to Kinematicz, our weekly physics podcast. As you can see, today we'll be focusing on the physics of longboarding.
When you push your board, you are inputting large amounts of energy. A good racing wheel is defined by its ability to conserve that energy, instead of releasing it all into the road. This makes it an efficient wheel. If a wheel is very efficient and keeps energy in the wheel as kinetic energy, it would make a great racing wheel. A good sliding wheel, also known as a freeride wheel, is the opposite of a race wheel. It has a low coefficient of friction and also transfers lots of its energy into thermal energy, allowing the layers of urethane to slowly peel off.
Thermal energy is the energy a substance has due to its particles moving. The faster the particles are moving, the more thermal energy. Now, thermal energy is often seen in longboarding during a slide. Sliding is a great way to slow down the board, but we know that energy cannot just disappear. It must be transferred in some way. Now, this energy is lost through heat, which is ultimately created by the friction between the wheel and the ground during the slide.
Projectile is key to longboarding when doing stunts and some tricks. One common use of projectile motion in longboarding is jumping from one ramp to another. It is important to know how fast he needs to travel in order to pick up enough speed to clear the distance between the two ramps. We know from projectile motion that if an object takes off and lands at the same height, the horizontal range is given by the equation shown on the screen. Here is a picture of how I derived that formula.
Sliding is a very popular form of longboarding. It involves breaking the static friction between the wheels and the road, and essentially riding sideways. Sliding, also known as freeriding, is the act of using kinetic friction to slow the rider and control the board around bends. There is also specific wheels designed for freeriding that have a very low coefficient of kinetic friction, thus slowing them to slide farther.
Newton's third law describes one of the many ways in which forces work. It states that for every action, there is an equal and opposite reaction. Now, this is crucial when it comes to pushing your longboard. When someone wants to move forward, they have to apply force backwards in order to push the board forwards. This is the perfect example of Newton's third law.
Acceleration is a huge factor of longboarding. Finding a proper hill to ride highly depends on the amount of acceleration you experience on that particular hill. If too much acceleration is experienced, the board begins to shake rapidly. This phenomenon is known as speed wobbles. Speed wobbles can be extremely dangerous and often cause tragic injuries and sometimes even death.
Sound energy is important in longboarding because the louder your bearings are, the more energy is being converted to sound energy. This causes less kinetic energy to be present. Good bearings sound like this. This means the energy is being used more efficiently and there is less resistance.
Static friction is the force that opposes the start motion of an object. Any stationary object must overcome the coefficient of static friction in order to gain kinetic energy. Now, in longboarding, a lot of riders like to spend time sliding, and in order to effectively initiate a slide, they must overcome the coefficient of static friction. If they cannot effectively do so, the board will stop and the rider will continue moving.
Conservation of energy states that the total mechanical energy at one point to another point stays the same. An example of this law being used in longboarding is when a longboard is on top of the hill. The only in total mechanical energy acting upon him is gravitational potential energy. When the longboarder reaches the bottom of the hill, all that mechanical energy is converted to kinetic energy. But the sum of the mechanical energy is the same as it was when the longboarder was on top of the hill.